So now we're going to move into section 2.3, and we're going to talk about the product rule for derivatives, the quotient rule for derivatives, and then these things called higher order derivatives. And this is probably going to take us about 2 days to get through all the pieces of this section. We're going to start by dealing with this product rule. And before we do that, I'd like you to take a look at this function h of x equals 3x minus 2 times 4x plus 1. Take a moment and get everything copied down. So the first thing I need to do is to try to convince you that this product rule needs to be more involved than just the derivative of the first part times the derivative of the second part. If it was just the derivative of this times the derivative of that, the derivative of the first part is just 3. The derivative of the second part is just 4. So by that logic, the derivative would be 3 times 4, which is 12. However, you know that we can do some distributing here. We can get 12x squared minus 8x plus 3x minus 2, or 12x squared minus 5x plus 2, minus 2. And I think that you know that the derivative of this is more involved than just a constant 12. So our product rule is not as straightforward as just derivative of this times the derivative of that. Here's what our product rule says. If I want to do the derivative of f of x times g of x, this is going to equal f of x times g prime of x plus g of x times f prime of x. And take a moment to get that copied down. The way that I remember the product rule is I've got two functions over here, a first function and a second function, and my product rule says it's the first times the derivative of the second plus the second times the derivative of the first. And I think I actually want to write down those words. My product rule is saying first times the derivative of the second plus the second times the derivative of the first. Again, I think I'll make the video pause for a moment so you can copy that down. So let's see how we can use this. Let's go back to that original example that I gave you, where we didn't actually find the derivative yet, but hopefully I convinced you that it's not just 3 times 4, it's not just 12. And I want to go apply my product rule to this. My derivative should be the first times the derivative of the second. Well, that first is just 3x minus 2 times, okay, your turn. What's the derivative of the second? Hopefully you said 4, or 4 plus 0, which just becomes 4, plus the second, 4x plus 1, times the derivative of the first. Well, again, your turn. What's the derivative of that first part? 3. I really shouldn't leave the answer looking like this. Let me do some work to clean it up. H prime of x equals, actually, how about you take a moment? I'll have the video pause again. You go distribute and combine like terms. Okay, we're going to get 12x minus 8 plus 12x plus 3. We are going to get 24x minus 5. If I look back at what I did when I FOILed my h of x, if you find the derivative of this, wouldn't this become also 24x minus 5? Now here's the issue. I feel like if I want to do the derivative of this problem, it would probably be easier not to use the product rule. Wouldn't it be easier just to do all your distributing, FOIL that thing out, and then take the derivative of that? We get the same answer. I actually think it's a little bit less work there. However, there are times when we have to use the product rule. Let me give you an example of that. Let's say we have y equals 2x times the cosine of x minus 2 times the sine of x. Y equals 2x cosine x minus 2 sine x. If I want to do the derivative of this first piece over here, there's no way for me to get around using the product rule. No amount of algebra will let me rewrite this in a form that doesn't involve a product. So here we go. There are a couple ways you could do this. I'm going to say that my product, let me get another color out. I'm going to say my product is 2x times the cosine of x. If I do that, first times derivative of the second, 2x times, okay, your turn, what's the derivative of cosine x? I hope you didn't say sine x, I hope you said negative sine x. Plus second, that's cosine x, times the derivative of the first, derivative of 2x is, your turn again, is 2. And I've used my product rule on this piece over here. Now, on the next piece, 2 times sine x. I could use my product rule. However, since one of the parts of the product is just a constant, how about I just use my constant multiplier rule that says, let's do 2, leave that out front, times just the derivative of this thing. That'll work. And I'm going to get minus 2 times the cosine of x. I couldn't do that trick over here because both of my pieces of the product involved variables. Over here, because this product was a constant times something with variables, I can use my constant multiplier rule. Take a moment and clean that up. We're going to get y prime equals negative 2x sine x plus 2 cosine x minus 2 cosine x, so that's going to be nice. And I can simplify this down to negative 2x sine x. Just a few comments. If you used the product rule on this 2 sine x, actually negative 2 sine x, I would have gotten first negative 2 times derivative of the second, cosine x, plus second cosine x times derivative of the first, derivative of a constant is just 0. I'm still just going to get negative 2 cosine x, which is what I did for my constant multiplier rule. The other thing, in the first part, I said my product was 2x times cosine x. We could also have said the product is, well, I'll leave that constant multiplier 2 out front and make my product just x times the cosine of x. Leave the 2 out front, use product rule on this thing. You'll still get the same 2 pieces that I got over there. And that's product rule.